We've always drawn a line between what's alive and what isn't. Trees are alive, rocks are not. You are alive, the planet beneath your feet is not. At least that's what we're taught. But the deeper we look into the universe, the blurrier that line gets. Galaxies form and evolve, stars are born, live and die, black holes devour. Even the empty vacuum of space isn't truly empty. It's boiling with quantum fluctuations, subtle energy, invisible forces holding everything together. The universe behaves in ways that mimic life. It creates complexity, it organizes chaos, it builds structures that persist and adapt. It may even be conscious, at least through us. Now, this isn't some sci-fi idea that the universe has a face or a voice or a personality. But ask yourself this: if something creates life, sustains it, evolves with it, and maybe even becomes aware of itself through it, is it really fair to call it dead? Before we even begin to wonder if the entire universe could somehow be alive, we have to ask something most people don't think too hard about. What actually counts as being alive? It seems like an easy question. Ask a kid, they'll tell you. Living things move, breathe, grow, eat, and maybe even have babies. That's the classic school definition. You eat food, you burn energy, you grow, and you react to stuff. Easy. That works great for squirrels and mushrooms, but then you meet something weird, like a virus. It doesn't eat, it doesn't move, it can't reproduce on its own. And yet it copies itself, mutates, spreads, and adapts to environments. Is that alive? Some scientists say yes, others say no. And that's when the whole idea of defining life starts to get murky. Now let's zoom out from the micro to the macro. Life, it turns out, is not a checkbox system. It's not always about having lungs or legs. It's about systems, processes that keep going. Processes that maintain themselves, repair themselves, and in some way try to persist. That's the key. Whether it's a plant slowly turning sunlight into sugar, or a dolphin jumping through waves, there's something underneath it all. A system that resists falling apart. A system that fights entropy. But what if I told you the universe, in some strange way, might be doing something similar? Let's put a pin in that for a second. First, back to the big question. What makes something alive? We often fall into a trap when answering this. We define life based on Earth's biology. Carbon, water, cells, DNA. That's what our kind of life looks like. But that's like saying music only counts if it's played on a piano. There are drums, guitars, synths. There are even sounds the human ear can't detect that we still consider music in the right context. Life might be the same. We just haven't met the other instruments yet. And here's where it gets interesting. There's a concept in systems theory called autopoiesis, a term coined by biologists Humberto Maturana and Francisco Varela. It's a fancy term that basically means self-creating. Something that maintains its structure, adapts to its environment, and keeps itself going despite changes. Cells do this, ecosystems do this. Some thinkers even argue that social systems, like cultures or economies, can show this property. They evolve, react to stress, reconfigure themselves to survive. Now here's the leap. If autopoiesis is a marker of life, could the universe qualify? The universe has structure. It evolves over time. It began in an explosive event, the Big Bang. And since then, it hasn't just been expanding randomly, it's been creating order. Stars form from gas clouds, planets form around stars, elements fuse and scatter. Life, at least on Earth, emerges. Intelligence wakes up, and then that intelligence starts asking questions, like the one we're asking right now. Some biologists define life as a system that processes energy and information in order to persist. That's broad. But by that definition, think about this. The universe processes energy constantly. It moves energy from stars to space to planets. It forms structures that trap energy and store it, like black holes or even human brains. It exchanges information, particles interact, atoms bond, light travels, gravity pulls. Could it be that we've been witnessing signs of life on a cosmic scale all along? But we've been so focused on petri dishes and microscopes that we missed the forest for the stars. Even philosophers have trouble pinning this down. Thinkers like Alan Watts and Thomas Nagel played with the idea that life and mind might not just pop out randomly in the universe, but be part of the way it works. Not an exception to the rules, but an expression of them. A consequence of how the universe behaves when it runs long enough, under the right conditions. And look, we don't have to get mystical about it. We're not saying the universe has a personality or thoughts like a human, but here's a quiet truth that's easy to overlook. Just because something isn't human doesn't mean it isn't alive. Take a tree. It doesn't talk, it doesn't dream, it doesn't have goals in the way we do. But it absorbs light, breathes out oxygen, sends signals through its roots, communicates with fungi underground, reacts to drought, defends itself with chemicals, and changes behavior based on its environment. That's life, just not life that looks like us. So when we talk about the universe possibly being alive, we're not imagining it sitting on a throne of galaxies thinking about its feelings. We're talking about it as a system that self-generates complexity, self-organizes, maintains processes, adapts across vast timeframes, and evolves, slowly, subtly, but surely. Traits that, when we see them on smaller scales, we instantly call life. And what's really fascinating is that humans for centuries have felt this intuitively. Ancient cultures saw the sky as alive. Some thought of the cosmos as a breathing being. Modern science tried to cut through that and say, no, it's just physics. But now physics is leading us in a strange circle, back toward mystery, back toward asking if maybe, just maybe, there's something more to this machine than bolts and gears. We might never settle on one perfect definition of life, but maybe that's because life itself isn't a category. Maybe it's a spectrum, a process, a direction things can move toward, given enough time and energy. And if that's true, then the next question isn't, is the universe alive or not? The real question becomes, how alive is it? If there's one thing life is good at, it's turning mess into structure. From a single fertilized egg, your body builds itself. Cells divide, specialize, form organs, communicate, adapt. Somehow, a chaotic pile of molecules becomes a working, thinking human being. But here's the weird part. The universe does something very similar. We're taught that the universe began with the Big Bang, an unimaginably hot, dense, chaotic state. No structure, no stars, no atoms, just energy. Pure, raw energy spreading outward. According to everything we know about entropy, things should have stayed chaotic. Disorder should have ruled. And yet, over time, that chaos gave birth to order. That's not poetry, it's physics. Out of expanding energy came matter. Out of matter came atoms. Atoms grouped into molecules. Molecules formed stars. Stars fused heavier elements. Those elements seeded planets. And on at least one of those planets, life began. And not just simple life. Complex, organized, self-aware life. Life capable of asking, why am I here? And what is all this? If you zoom out, that entire process, from randomness to structure, from energy to awareness, looks suspiciously like a single unfolding pattern, like a direction, like a process that knows how to build complexity. Not consciously maybe, but effectively. And that's not just a poetic interpretation. Scientists actually have a term for it: emergent complexity. It's when simple rules, followed over time, create incredibly complex outcomes. Pioneered by scientists like John H. Holland, who developed the theory of complex adaptive systems, and Stephen Wolfram, known for his work on cellular automata and computational systems. This concept shows how intricate behavior arises from simple components. You see it in biology, where the rules of DNA and protein folding somehow build living organisms. You see it in computer science, where simple bits and logic gates give rise to programs, algorithms, artificial intelligence. You even see it in traffic systems, ecosystems, markets. The universe, it seems, is the ultimate example of this. What's striking is how consistently the universe leans toward this buildup of complexity. Not always in a straight line. There are collapses, disasters, extinctions, but the general trend keeps climbing. From particles to planets, from chemistry to consciousness. The more time you give it, the more it builds. Not randomly, not aimlessly, but with a kind of rhythm. Take galaxies. They're not just floating around like dust in a breeze. They rotate, hold stars in spirals, orbit black holes at their centers. Many form structures like filaments and walls that stretch across the cosmos. Giant, intricate networks of galaxies arranged almost like neural pathways in a brain. That's not metaphor. Scientists have literally compared maps of the cosmic web to the structure of human neurons. The similarities are eerie. Then there's Earth. Look at our planet from space, and it's hard not to see it as a system. Clouds swirl, oceans flow, land reshapes itself. Beneath that surface, ecosystems churn. Food chains, migration cycles, climate feedback loops. Life modifies the environment, and the environment in turn shapes life. There's no central control, no architect, just billions of interactions forming something far more complex than any of its parts. You could argue this is just how physics works. Gravity pulls things together, thermodynamics pushes them apart, chemistry makes bonds. Sure, but that doesn't explain why complexity survives, why it builds on itself, why it lasts. In physics, there's something called non-equilibrium thermodynamics, the study of systems that stay ordered despite the entropy trying to pull them apart. Developed and advanced by pioneers like Ilya Prigogine, who won the Nobel Prize for his work on dissipative structures and self-organization in open systems, and Lars Onsager, known for his reciprocal relations in irreversible processes. This field explores how complexity arises far from equilibrium. Life is one example, hurricanes are another. But so are stars, galaxies, and even consciousness. These systems don't fight entropy by stopping it, they ride it. They use flows of energy to build stability, even as the overall universe trends toward disorder. That's not random, that's behavior. Not in the sense of having intentions or goals, but in the sense of responding to conditions in a way that keeps the structure going. Now take that idea and scale it up. What if the universe, as a whole, is one massive non-equilibrium system? Not static, not passive, but constantly shaping itself, constantly rearranging and forming new patterns, just like living systems do. It's easy to look at stars and planets and say, those are just balls of gas and rock. But so is your body, at a basic level. What matters is how the parts are organized, how they interact, and how they adapt over time. Think about the fact that atoms from exploded stars formed your blood, your bones, your brain. Think about the idea that the carbon in your cells, the iron in your blood, and the oxygen you breathe all came from supernovae, massive stellar deaths. That's not metaphor. That's astrophysics. You were literally built from the remains of collapsed stars. And now you, the byproduct of that collapse, are sitting here wondering if the thing that made you could be alive itself. That's the loop. That's the echo that keeps coming back. Life didn't appear in the universe like a visitor. It appeared from the universe as an extension of its own processes. That alone blurs the boundary between creator and creation. What makes it even more compelling is that this pattern shows up across scales. At the smallest scales, quantum particles flicker into and out of existence, interact and form stable systems. At the larger scales, galaxies cluster, merge, and evolve. In between, life appears, evolves, and develops minds that can reflect on existence itself. You could argue that these are just coincidences, that it's just the laws of physics doing their thing. But ask yourself, if an alien saw all this happening, from the Big Bang to brains-building telescopes, would they really say this universe is just a thing? Or would they say it behaves a little too much like it's alive? It's not about slapping a label on the cosmos. It's not about proving the universe has a pulse or a heartbeat. It's about recognizing that the same forces that build living things, from cells to civilizations, are baked into the bones of the universe itself. And maybe, just maybe, that's not accidental. If the universe were a bit lazier, just slightly off in its math, we wouldn't be here. And I don't mean humans, I mean anything. No galaxies, no stars, no atoms, just a cold or chaotic void. Nothing interesting, no chance of life, no one to ask questions. That's not drama, that's the actual situation we're in. Because when you look closely at the numbers that govern the universe, the constants, the ratios, the forces, they're not just close to right, they're absurdly exact. So exact that if you tweaked some of them by a hair's width, everything falls apart. Take gravity. If it were just a little weaker, matter wouldn't clump. No stars, no planets, no people. But if it were stronger, the universe would have collapsed on itself early on. No time for anything to form. Either way, no structure, no life. Same with the strong nuclear force, the thing that holds protons and neutrons together in the nucleus. Adjust it slightly and atoms can't form. No chemistry, no biology, just particles drifting without meaning. Even the ratio of the electromagnetic force to gravity has to sit within a razor-thin margin. If it were even a little different, stars would burn too fast or never ignite at all. But why? Why are all these numbers just so perfectly aligned to allow life? Not just human life, but any life. This is called the Anthropic principle. It sounds fancy, but at its core, it's pretty simple. It's the idea that the universe must have the properties that allow conscious life to exist, because if it didn't, we wouldn't be here to notice. It's a kind of cosmic well-duh moment. But it also opens a door to something far stranger. There are two flavors of the Anthropic principle: weak and strong. The weak Anthropic principle just states the obvious. We observe the universe in a way that supports life, because we're here. It's like saying you see air because you need air to be alive. It doesn't explain anything, it just acknowledges the situation. But the strong Anthropic principle, that one's a lot bolder. It suggests the universe must have these life-friendly properties because life is somehow meant to exist. It's not an accident. It's built into the design. Like the universe wasn't just capable of producing life, but destined to. And that's where things start to feel less like science, and more like something else entirely. Because when you look at the odds, the improbability of it all, it starts to resemble intention. Not proof, not evidence, but a deep weirdness you can't shake. Like someone tossed a dart at a wall from 1 billion miles away and hit the bullseye. You can say, well, if they missed, we wouldn't be here to talk about it. Sure, but that doesn't make the shot any less bizarre. One way scientists try to make sense of this is by bringing in the multiverse idea. Maybe our universe isn't special. Maybe there are countless universes, most chaotic, most lifeless, and we just happen to live in the rare one where things work out. In that view, our universe isn't alive or designed. It's just a fluke in an infinite lottery. But here's the catch. We've never seen these other universes. We can't test them. We don't even know if they exist. So it's still just another way of saying, yeah, it's weird, but here we are. The other possibility is that we're looking at this the wrong way. That maybe the universe isn't just a passive setting that accidentally gave rise to life, but that life, structure, and maybe even consciousness were always going to happen. That they're part of how the universe expresses itself. Like waves are part of the ocean, like thoughts are part of the brain. Because when you really think about it, life is not a separate thing from the universe. We are made of it, literally. Your body is built from atoms that came from stars. Your thoughts are made from electrical signals powered by molecules that came from plants that grew in sunlight from a star that formed from dust that came from the Big Bang. There's no outside influence here. It's all the universe doing its thing. So maybe the universe isn't fine-tuned for life. Maybe life is the universe tuning itself. Maybe it doesn't make sense to separate us from the cosmos and act surprised we fit in so well. We're not outside observers, we're inside participants. Our existence is the universe reflecting on itself, asking itself questions, realizing its own complexity. And here's the part most people skip. This fine-tuning didn't stop after the Big Bang. It continues. The evolution of stars, the formation of planets, the development of ecosystems, even the emergence of consciousness. All of it follows patterns that seem just balanced enough to keep building, just unlikely enough to be astonishing, just stable enough to last. Ask a physicist why the constants are what they are, and most will tell you that's just the way it is. But that's not an explanation. It's a placeholder. And deep down, we know that. We expect randomness to look random. But this doesn't feel random. It feels balanced. It feels directed. It feels, whether we like it or not, alive. Not alive like a puppy or a plant, but alive in the sense of being structured, responsive, creative. A system that builds, that adapts, that seems to notice when things work and keeps doing them. Maybe that's just our pattern-seeking brain making shapes in the dark. Or maybe the dark is full of shapes we've only just started to see. Consciousness feels like the final line, the thing that separates the living from the dead, the aware from the unaware, the experiencer from the background. It's easy to assume it starts and ends in the brain. You wake up and suddenly the lights are on. You go to sleep and they're off. Consciousness seems local, personal, humans. But what if that's not the full picture? There's a theory, gaining quiet traction in both science and philosophy, that turns this idea completely inside out. It's called Panpsychism. And it asks something wild. What if consciousness isn't something that shows up late in brains, but something that was always here from the very beginning? It doesn't mean that rocks have thoughts or chairs feel boredom. Panpsychism isn't about making everything human. It's about taking the mystery of awareness and pulling it back to its roots. Instead of seeing consciousness as an emergent property of complexity, it asks if it could be a fundamental feature of the universe, like space, time, or charge. Think about it like this. We already accept that matter has properties we can't see. A particle has mass, spin, electric charge. You can't touch these things. They just are. So, why not one more property? Something like proto-consciousness. Not full-blown thought, not feeling, but the most basic shimmer of awareness. Just enough to matter when enough of it stacks up. This isn't fringe. Philosophers like David Chalmers, famous for defining the hard problem of consciousness, have suggested that maybe we're not getting anywhere with consciousness because we're looking in the wrong place. We keep trying to explain awareness as a side effect of neurons, hoping it'll pop out of the math. But it never quite does. Panpsychism flips that. It says, start with consciousness as fundamental, not accidental. Let's pause for a second and ask, what even is consciousness? We don't really know. It's not intelligence. Intelligence can be mimicked by algorithms crunching data, solving problems, or playing chess without ever feeling a thing. It's not memory either. Memories are just stored information, retrievable by neurons or hard drives alike. It's the raw experience of being, the feeling of red, the sound of a violin, the sting of regret. These aren't physical things, they're experiences. And no matter how far we break down the brain into cells and circuits, we never quite land on experience. We see inputs and outputs, but not the thing that lives in between. That's the mystery. You can describe a brain with equations, but you can't describe what it's like to be you using math. So, panpsychism doesn't try to explain consciousness away. It accepts it as a building block, and suddenly the universe starts to look different. If consciousness is baked into matter, just in a raw, primitive form, then every atom has a little bit. Not thoughts, not ideas, just some quality of experience. When atoms form molecules, and molecules form cells, and cells form brains, those bits of experience combine into something richer. Just like how thousands of neurons, each pretty simple, create the mind of a person. It's kind of like pixels. One pixel is meaningless, but arrange them the right way and you get an image. The image wasn't hiding inside any one pixel. It was in the pattern. Panpsychism suggests consciousness might be the same, hidden not in individual parts, but in the way the parts come together. So what does this have to do with the universe? Well, if matter and energy have some seed of awareness, and the universe is made of matter and energy, then maybe the universe isn't just building complexity. Maybe it's building conscious experience. Maybe it doesn't just contain observers. Maybe it is an observer in the broadest possible sense. That might sound far out, but think of it this way. If consciousness is everywhere, then we're not isolated islands of awareness floating in a sea of dead stuff. We're part of the sea. We're waves in a conscious ocean, temporary, unique, but made of the same thing as everything else. And here's the twist. This view doesn't conflict with science. It doesn't break the laws of physics. It doesn't require new particles or dimensions. It just asks us to take what we already know and reinterpret it from a different angle. Because when you think about it, the physical world doesn't explain itself. It follows rules, it behaves predictably. But why it exists at all, or why those rules feel the way they do, that's still blank space. Panpsychism doesn't fill in all the blanks, but it opens a door. It asks, what if we've been looking for consciousness in the brain when it's actually everywhere, and the brain just focuses it like a lens? Now take that idea and aim it at the cosmos. Galaxies swirling, matter clustering, gravity weaving invisible webs through space. All of that, under this theory, could be more than mechanics. It could be behavior. Not conscious in a human way, but in some distant, unfamiliar way that we can't quite measure. Like a mood the universe has. A hum too deep for us to hear. And maybe, just maybe, that hum becomes a voice when it flows through us. That's where things get personal. Because if panpsychism is even partially right, then consciousness isn't something that happens to the universe. It's something the universe does, through stars, through animals, through people, through us. Sentience, the felt pulse of experience, sharpens this voice in beings like us, turning the universe's quiet awareness into the vivid joys, pains, and colors of a lived moment. We don't just see the universe, we're one way it sees itself. And that means that awareness isn't rare or accidental or limited to one species on one planet. It's something much bigger, much older, woven into the fabric of everything. Not proof, not certainty, but a possibility that shifts the way you look at a rock or a tree or a patch of sky. Because if consciousness is everywhere, then nothing is truly empty. If you shrink down far enough, way beyond cells, beyond atoms, down to the level of electrons and quarks, the universe starts behaving strangely. Not just complex, not just fast, but straight up weird. At this level, reality doesn't feel solid anymore. It becomes slippery, like trying to hold water with your hands. Particles can be in multiple places at once. They can tunnel through barriers. They don't even seem to have definite positions until we look. And that last part, the act of looking, is where things really get unsettling. Because in quantum physics, observation changes everything. You've probably heard of the double slit experiment. It's one of those classic thought-shattering experiments that refuses to be forgotten because, frankly, we still don't fully understand what it's telling us. Here's the quick version. Fire tiny particles, like electrons or photons, at a wall with two slits. If no one is observing, they behave like waves. They go through both slits at once and create an interference pattern, as if they're interfering with themselves. But the moment you observe which slit they go through, just the act of measuring them, they stop acting like waves and behave like particles. The interference pattern disappears. The outcome literally changes depending on whether or not they're being watched. That's not a trick. That's repeatable, verified, and fundamental to how quantum systems behave. The universe, it seems, responds to observation. This is called the observer effect, and it's not just a weird footnote. It's baked into the equations of quantum mechanics. Without an observer, there's only a cloud of probabilities. With an observer, you get a specific outcome. Now take a breath. Because this doesn't mean consciousness magically forces particles to act a certain way, not in the mind over matter kind of sense. But it does mean there's a link, a strange, unavoidable link, between what exists and what is observed. So, here's the question no one likes to ask out loud. Before there were any observers, did the universe exist in the way we understand it? Did it have definite states? Or was it just an infinite superposition of possibilities, waiting for the first conscious glance to collapse into something real? That's not science fiction. That's a real puzzle in physics. Some interpretations, like the Copenhagen interpretation, say that quantum systems don't have definite properties until measured. Others, like the many worlds interpretation, dodge the issue by saying all outcomes happen in branching universes. But even that doesn't escape the fundamental weirdness. Observation seems to play a key role in shaping what we call reality. And if you think about that too long, it messes with your head. Because suddenly, consciousness isn't a passive passenger in the universe. It's part of how the universe unfolds. It's not sitting back and watching the movie, it's embedded in the projector. The act of observing, measuring, perceiving, these aren't add-ons. They might be structural. And that's where things twist back into our bigger question. Could the universe be alive? Because if observation shapes the universe, then observers aren't just side effects of cosmic evolution. They're participants. They're mechanisms. They're features of how reality functions. And if that's true, then life isn't something the universe tolerates. It's something the universe needs. Not for survival in the biological sense, but for realization. For collapsing potentials into actualities. For turning probabilities into facts. In a way, the universe doesn't just make observers. It depends on them. This opens the door to all kinds of unsettling thoughts, like, what was the universe doing before the first conscious beings emerged? Was it still real? Or was it a vast soup of quantum fog slowly settling into form the moment life began to look? Again, this isn't mysticism. This is a real, open question in physics. It's not just humans either. Anything that performs a measurement, detectors, sensors, even natural interactions, can collapse a quantum wave function. But when it comes to experience, to the kind of observation that feels like something, consciousness still sits in a strange place. A place we don't understand. Some physicists have proposed that consciousness itself might be what causes wave function collapse. That it plays a role in bringing potential realities into actual ones. This idea isn't mainstream, but it keeps coming back, because nothing else explains it cleanly either. And here's the strange symmetry. If the universe creates conscious observers, and those observers help shape the universe, that's a feedback loop, a system aware of itself. Not just through human eyes, through any awareness, at any level. Maybe it starts small, primitive, barely there. But over time, over billions of years of cosmic evolution, maybe that loop gets stronger, clearer, sharper. Until one day, it builds something like us. And we look back, we ask questions, we build microscopes and telescopes and equations, and in doing so, we collapse wave functions. We fix reality in place. In a weird way, we're not just made of the universe, we're finishing its sentences. So what does this mean? It doesn't prove the universe is alive, but it pushes us to rethink what alive might even mean. Maybe it's not about cells and blood and heartbeat. Maybe it's about responsiveness, adaptation, the ability to form feedback loops, to evolve structures that observe and react. And the quantum world is nothing but feedback loops. You affect a system by measuring it. That's a loop. You influence outcomes by being part of the experiment. That's a loop. The universe becomes more defined as we interact with it. Loop. So maybe the real question isn't, is the universe alive? Maybe the question is, has it always been in the process of waking up? In the 1970s, a scientist named James Lovelock proposed something radical. What if Earth isn't just a planet with life on it, but a living system in itself? That idea became known as the Gaia hypothesis. And while it was controversial at first, it struck a chord. Not just with environmentalists or philosophers, but with scientists too. Because when you really look at Earth, it doesn't just support life, it regulates it. The atmosphere stays within a certain range. Oceans don't boil or freeze completely. Carbon levels rise and fall, buffered by forests and oceans. Even temperature seems to self-correct over time. It's not random, it's a feedback loop. Life influences the planet, and the planet in turn influences life. It's a two-way conversation. Not through language, not through thought, but through behavior. And here's the leap. What if that same logic applies not just to Earth, but to the entire universe? It's not about turning the universe into a giant person. This isn't some cosmic being sitting out there with intentions or desires. That's not what Gaia theory ever meant. It's about systems. It's about regulation, feedback, adaptation. It's about asking, does the whole act in a way that preserves the parts? If Earth can behave like a living organism, balancing itself without a central brain, could the universe be doing something similar, just on a much bigger scale? Start with energy. One of the strangest things about our universe is that most of its energy isn't visible. In fact, more than 95% of the universe is made of things we can't see or touch. Dark matter and dark energy. They're invisible. But their effects are real. They shape galaxies. They control the rate of expansion. They hold things together that should be flying apart. Nobody knows what these forces actually are. But we know what they do. They keep the large-scale structure of the universe stable. That sounds a lot like regulation. Now think about the cosmic microwave background. The leftover glow from the Big Bang. It's not just noise. It's an incredibly even temperature across space, with tiny fluctuations that seeded galaxies. The balance is astonishing. Too hot or too cold in the wrong places, and structure wouldn't have formed. Stars wouldn't have lit. Life wouldn't have had a shot. But somehow, those early conditions set everything up with just the right ingredients. Over billions of years, the universe has been unfolding, but not chaotically. There's a rhythm. Galaxies form and group into clusters. Black holes regulate star formation. Supernovae spread heavy elements, creating new planets which, at least here, gave rise to life. At each level, there's tension between chaos and order. And over, balance emerges, not as static harmony, but as a dynamic equilibrium. In Gaia theory, this happens through feedback. For example, when CO2 levels rise, plants grow faster, sucking more of it out of the atmosphere. If temperatures climb, clouds increase, reflecting more sunlight. It's not perfect, but it's persistent. The system reacts to preserve itself. So what's the feedback system for the universe? We don't know exactly, but we're starting to see signs. Take cosmic inflation, that brief explosive expansion right after the Big Bang. It didn't just stretch space, it flattened it, smoothed out irregularities, made the universe usable. Some models suggest inflation stopped at just the right moment to allow stars and galaxies to form. Why did it stop? Why didn't it keep going forever, or fizzle out too soon? Nobody's sure. But the result was a universe tuned for structure. Not just dust flying through a void, but stars, planets, chemistry. The ingredients for complexity. That looks again like regulation. Even now, dark energy seems to be keeping the universe's expansion in check, not collapsing too fast, not tearing itself apart. We don't know why, but we know the result, a kind of stability across unthinkable scales. And what about life? That strange phenomenon that somehow manages to appear, persist, and evolve, even in hostile conditions. Gaia theory on Earth doesn't treat life as a fluke. It sees it as part of the regulatory system. Life helps maintain the balance. It transforms the planet. And maybe, if we zoom out far enough, life in the universe plays a similar role. Maybe life isn't just tolerated by the universe. Maybe it's used by the universe, subtly, indirectly, to help guide its own development. This idea might sound speculative, but think about how feedback works. It doesn't need intention. A thermostat doesn't want to regulate your house temperature. It just reacts to conditions. You change the temperature, the system responds. That's it. If life is part of a universal feedback system, it wouldn't need to know it. We wouldn't need to be conscious of it. But our existence, our actions, our knowledge, our choices might ripple back into the system that created us. That's already happening. Through science, we shape energy. Through technology, we alter the planet. Through observation, we study the universe. And through those observations, maybe we influence it in subtle ways we haven't yet understood. There's even a theory called the participatory anthropic principle, which suggests that the universe requires observers not just to be seen, but to exist in a certain way. In that view, life plays a role in selecting the kind of universe that gets locked in. That's a long shot. But it's part of a growing realization that the universe might not be entirely mechanical, that it behaves in ways we associate with living systems, self-organizing, self-correcting, long-lasting. Maybe Earth isn't special in behaving like Gaia. Maybe it's just one organ in a much larger organism. A galaxy might be another, a black hole might be a valve, a supernova might be a circulatory burst, and the web of cosmic structure might be the nervous system of something we don't yet have the tools to comprehend. Again, this isn't about fantasy. It's about noticing patterns. And when you step back, the pattern is clear. The universe doesn't drift toward chaos. It builds, it balances, it adapts, not perfectly, not forever, but enough to ask the question, if Earth acts alive and the universe acts like Earth, where do you draw the line? You, your hands, your thoughts, your breath are built entirely from atoms forged in stars. The calcium in your teeth, the iron in your blood, the carbon in your brain, none of it existed at the beginning of the universe. It was created in the hearts of massive stars that lived and died billions of years ago, exploded, scattered, reassembled. And eventually, those pieces became you. That's not a metaphor, that's astrophysics. But here's the strange part. Those same atoms that once floated through deep space are now having thoughts about the universe. The universe isn't just out there, it's in here, looking out, asking itself questions, trying to understand itself. Think about that. We are not separate from the stars. We are what the stars became when they learned to think. The universe gave rise to life. Life gave rise to minds. And now those minds are mapping galaxies, writing equations, simulating the birth of stars, arguing about consciousness, wondering what it all means. The universe is studying its own origin through us, through science, through curiosity. We are not separate from the cosmos. We're part of its process. That's more than just poetic, it's structural. You're not floating in space, you're made of space. The same quantum fields, the same particles, the same energy flows that shaped stars and galaxies are humming in your cells. And somehow, that same material organized itself into something that can reflect, imagine, fear, hope, wonder. In any other context, we'd call that feedback, a loop, a system aware of itself. This brings us to the question that quietly underpins everything we've talked about so far. What is the role of awareness in a universe like this? Is it just a side effect? An evolutionary tool that helped apes avoid predators and invent Wi-Fi? Or is it something deeper? Carl Sagan once said, "We are a way for the universe to know itself." At first glance, that sounds poetic, maybe too poetic for hard science. But look again. That's not a claim about human importance. It's a recognition of a process. Something vast becomes something small. And in that smallness, awareness arises. Not to dominate, just to know. Knowing is strange. It's not mechanical. You can describe a chair, but the act of sitting in it is something different. You can analyze a brain, but that doesn't explain what it's like to hear music or remember a dream. Awareness adds something that pure physics doesn't capture. A dimension that isn't spatial, but experiential. So, here's the deeper possibility. What if awareness is not the byproduct of the universe, but one of its tools, not in a supernatural sense, just in a functional one? The universe creates structures. Structures create life. Life creates minds. Minds ask questions. Questions lead to understanding. And understanding feeds back into action. That's not mystical, it's a feedback loop. A system pushing itself further, becoming more aware of what it is, of how it works. We see this in evolution. Organisms become more complex over time, not always, but often. Brains get bigger, senses get sharper, social structures form, language evolves, the ability to model the world improves. And eventually you get a species that builds telescopes and particle accelerators and wonders about the heat, death of the universe. Now step back. What is that, if not the universe thinking about itself? It's easy to feel small in all this, and in some ways, you are. A single person, in a brief moment of cosmic time. But in another way, you're playing a role no particle or planet has ever played before. You're aware. And through you, the universe isn't just existing, it's noticing. Maybe that's why the universe feels so strangely balanced for life. Not because it was designed for us, but because this is the only way it gets to experience itself. Through eyes, through brains, through curiosity. That doesn't make humans special. It doesn't put us at the center. But it does blur the line between subject and object, between observer and observed. It reframes the entire situation. We're not just looking at the universe from the outside. We are the universe, looking at itself from the inside. Each thought you have about the stars, each question you ask about time or energy or existence, is part of the universe's ongoing process of self-discovery. It's not a person, it doesn't have a plan, but it might have a path, a direction, from chaos to order, from matter to life, from silence to awareness, and now to reflection. By now, it's tempting to start seeing the universe as something alive. Maybe not alive like an animal, but alive in a broader systems-based sense. Self-organizing, evolving, even aware. But let's not get carried away. Before we drift too far into cosmic metaphors, it's worth pausing and asking the obvious. Are we just reading too much into the patterns? Because that's something humans are very good at. Seeing meaning where there might not be any. We find faces in clouds, shapes in constellations, meaning in coincidences. And when we look at something as big and mysterious as the universe, our brains almost want to personify it, to give it character, behavior, purpose. That's not science, that's psychology. So let's look at this whole idea with cold eyes for a minute. First, just because something behaves like it's alive, doesn't mean it is. Hurricanes form, spin, grow stronger, and then die. They change shape, feed on energy, and even adapt to external forces like wind or temperature. But we don't say hurricanes are conscious. They're systems. Dynamic, yes. Complex, yes. But alive? No. The universe might be the same, just a far more massive, far more intricate system. And when we talk about complexity emerging over time, galaxies forming, stars lighting up, life arising on Earth, we're describing processes that can be fully explained by the laws of physics and chemistry. No mystical ingredient, no secret signal guiding the show. Gravity pulls matter together. Fusion creates energy. Natural selection favors traits that survive. All of this can look like intentional behavior, but that doesn't mean there's intent behind it. Then there's the anthropic principle, the idea that the universe seems fine-tuned for life. It's a compelling thought, but many scientists argue it's not a clue about design or awareness, it's just selection bias. Of course, we live in a universe that allows for life. If it didn't, we wouldn't be here to wonder about it. It's like winning the lottery and then thinking, wow, these numbers must have been picked for me. When in reality, you're just one of the few who happened to win, while countless others didn't. And as for consciousness being everywhere, the idea from Panpsychism, it's a fascinating theory. But there's still no evidence that particles or molecules have any kind of subjective experience. Awareness is incredibly hard to define, let alone detect. And without a way to measure it, panpsychism remains a philosophical idea, not a scientific one. Even quantum mechanics, with all its observer-related weirdness, doesn't prove that consciousness creates reality. Most physicists interpret the observer effect as a matter of measurement interaction, not mental awareness. The detector doesn't need to be alive, it just needs to interact with the system. No mind required. That brings us to perhaps the biggest counterpoint. The universe doesn't care. It's vast, it's cold, it's indifferent. Supernovae destroy entire star systems without a pause. Black holes tear matter into pieces. Life, as far as we know, is fragile, rare, and extremely local. One solar flare could end it all tomorrow. If the universe is alive, it's not the nurturing kind. So maybe the idea of a living universe is comforting. Maybe it helps us feel connected, but that doesn't make it true. Patterns can emerge from randomness. Order can arise from chaos. Life can appear from matter without meaning behind any of it. Maybe the truth is simpler. Maybe the universe isn't alive, it's just good at organizing itself. Maybe what we see as purpose is just the result of survival. Maybe what we interpret as awareness is just structure, scaling up, and maybe we're not the universe becoming conscious. Maybe we're just lucky chemistry, asking romantic questions. And yet, even the critics, the skeptics, the scientists who reject the idea of a living cosmos, they still agree on one thing. Something very strange is happening here. The universe didn't have to produce complexity. It didn't have to lead to minds or questions or wonder. It didn't have to lead to us, but it did. Somehow. So, while the idea of a living universe might not be provable, it's also not something you can fully dismiss, because if the universe isn't alive in the way we understand life, maybe the problem isn't with the universe. Maybe the problem is with our definition of life. We've come a long way, from particle physics to planetary feedback systems, from panpsychism to quantum uncertainty. We've talked about galaxies that look like neural networks, stars that create the elements we're made of, and the possibility that consciousness might not just be a side effect of the universe, but something woven into its structure from the start. So, could the universe be alive? Well, that depends on what you mean by alive. If you're asking whether the universe has a heart, or breathes, or thinks like we do, the answer is probably no. It doesn't have a pulse, it doesn't feel joy or sadness, it doesn't have goals or intentions. If it's alive, it's not alive in any way we've ever seen before. But if alive means capable of building complexity, resisting disorder, self-organizing, adapting, generating awareness, then the case gets harder to dismiss. Maybe the mistake isn't in asking the question, maybe it's in how we define the terms. We tend to think of life as a box. DNA goes in the box. Reproduction, metabolism, response to stimuli, check all the boxes, and you have life. But what if life isn't a checklist? What if it's a direction, a process, a pattern that appears when enough structure and time come together? By that measure, the universe doesn't just contain life. It follows the same rules life does. It evolves. It learns. It creates feedback loops. It makes observers out of stardust, and then lets those observers turn around and ask, what are we? That alone is remarkable. That alone blurs the line. Because if you were trying to describe a living system from the outside, what would you look for? You'd look for structure, for change, for self-regulation, for growth, for something that reacts, adapts, reflects. The universe does all of that. Not randomly, not constantly, but undeniably. And maybe that's the problem. We keep trying to fit the universe into the narrow definition of biology. But biology is a tiny piece of the story. The universe was here before cells, before water, before planets, and yet it still found a way to bring all those things into being. So maybe the better question isn't, is the universe alive? Maybe it's, what kind of life could a universe be? Maybe it's something slow, something spread across light years and billions of years. Something that builds layer upon layer until it starts to notice itself. Maybe not all at once, maybe not everywhere, but enough. Enough to ask the question. Enough to wonder if asking the question is exactly what the universe was waiting for. Not because it has a plan, but because this is just what it does. If the universe is alive, then asking what is my purpose might be the wrong direction. The better question is, what role are you already playing without even realizing it?